Welcome. We continue with our discussion on the example shown here. Recall that to solve a linear programming problem with the Simplex method, one of the requirements we need is that all the variables are restricted to non-negative values. In the example shown here, we wish to rewrite each of the following constraint sets in standard form. We have observed that in part A, x1 is non-positive, whereas in part B, x2 is unconstrained in sign. It can be positive, negative, or zero. Both of them do not fulfill requirement 3 that all variables should be restricted to non-negative values. To deal with the first issue that a variable is restricted to being less than or equal to 0 instead of greater than or equal to 0, we can apply a substitution of variable. Let y1 equals to the negative of x1. Then, as x1 is less than or equal to 0, we have y1 to be greater than or equal to 0. Next, we substitute negative y1 for x1 to all the places in which x1 appears. Then we should get negative 2y1 plus x2 plus x3 greater than or equal to 35, negative y1 plus 2x2 less than or equal to 10, where y1 is greater than or equal to 0 as well as x2 and x3. We can see that now all the variables in the constraints set are now restricted to non-negative values. At the moment, our constraints are not yet stated as equations. We apply the method we have discussed before. For the first constraint, we subtract a non-negative surplus variable E1 and add a non-negative artificial variable A1. For the second constraint, we add a non-negative slack variable S2. Our constraint set is now rewritten as this form, where all the variables are non-negative, all the constraints are stated as equations, and the right side of each constraint is non-negative. It is now in standard form. If we manage to find a value of y1 that satisfies all these constraints here, we can obtain the corresponding value of x1 that also satisfies all the constraints here by simply taking the negative value of y1. To deal with the second issue that a variable is unconstrained in sign, we can replace this variable x2 by the difference of two non-negative variables. That is, we can replace x2 by y2 minus w2, where both y2 and w2 are non-negative. Then we substitute y2 minus w2 for x2 to all the places which x2 appears. We can do so because we can use y2 minus w2 to form any possible value of x2, no matter whether x2 is positive, negative, or 0. For example, if x2 shall be a positive value, we shall have y2 and w2 in such a way that y2 is more positive than w2 by a suitable amount. If x2 shall be a negative value, we shall have y2 and w2 in such a way that y2 is less positive than w2 by a suitable amount. If x2 shall be 0, we shall have the same value for both y2 and w2. In this case, we should get 2x1 plus y2 minus w2 less than or equals to 20, x1 plus y2 minus w2 less than or equals to 18, where x1, y2, and w2 are all greater than or equals to 0. We can see that all our variables in the constraints set are restricted to be non-negative values. At the moment, our constraints are not yet stated as equations. We apply the method we have discussed before. For the first constraint, we add a non-negative slack variable s1. For the second constraint, we also add another non-negative slack variable s2. Our constraint set is now rewritten as the following form, where all the variables are non-negative, all the constraints are stated as equations, and the right side of each constraint is non-negative. It is now in standard form. If we manage to find the values of y2 and w2 that satisfy all the constraints here, we can obtain the corresponding value of x2 that also satisfy all the constraints here. The value of x2 will be equal to y2 minus w2. Please make a pause and attempt the exercise and check the answers afterwards.